This is a QuickField simulation example, ISO 10077 standard, test case 9, PVC shutter profile. This is the web page of this example. Here you can find all the necessary information that you want. This is the geometry model with blocks and boundary conditions. This is the cool side on the bottom and the warm side on the top, and on the left and on the right we have zero flux boundary conditions. Also we have values of channel conductivity of PVC and the gas filling. Our task is to calculate channel conductance of the frame in accordance with the ISO standard. We have a reference channel conductance given here in commas. Also, we can get some comments regarding convection coefficients, and the crucial moment regarding this problem is that in order to calculate equivalent channel conductance, one should first calculate equivalent channel conductivity of air blocks, because in reality heat transfer contains convection and radiation. So in order to take this into account, we use accompanying Excel spreadsheet. Now let's go to QuickField. First, let's take a look at the problem properties. This is a steady state heat transfer problem, and model class is a plane parallel one. Now let's take a look at the geometry. We have 4 air blocks with the same value of the channel conductivity. It's the initial value for subsequent calculations. And also we have 2 PVC blocks. As I said before, we have boundary conditions on the edges, symmetry on the left and on the right, and the convection boundary condition on the bottom and on the top. Now let's get to the Microsoft Excel. This is the accompanying Excel spreadsheet. Here we have a brief instruction on how to deal with this document. And well, first we have to list air blocks in the first column. And when we type 1 or 2 depending on the block type, here in the second column, and then we set initial value of the channel conductivity for each of the air block. After that we start calculations. We will make a few iterations in order to get appropriate values of lambda. We will use these values. Let's get to QuickField again. In order to calculate equivalent thermal conductance, I should add the relevant edges to the integration contour. I did, and now I push the integral calculator button and calculate heat flux. This is the value. Now I type this value for the temperature difference, and then I get the value of equivalent thermal conductance. One can see that this value is pretty close to the reference one.